In this lesson, we're going to continue with what we studied in section 2.4 using the tangent ratio to find side lengths, but now we're going to apply it to word problems. So in our first example, it says that at a horizontal distance of 200 meters from the base of an observation tower, the angle between the ground and the line of sight to the top of the tower is 8 degrees. How high is the tower to the nearest meter? Well, like in many word problems, the first thing we need to do is to draw ourselves a diagram of the situation. So we have our ground and we have our tower, a very straight tower. Let's try that again. And it says that the angle between the ground and the line of sight to the top of the tower. So the angle from the ground to the top of the tower is given as 8 degrees. And it says we are standing 200 meters from the base of the tower. And the question is, what is the height of the tower? So again, we're given a right triangle. We're assuming the tower is perpendicular to the ground, and we want to find the height. So therefore, we can use the tangent ratio again. This time, we would say the tan of 8 degrees is equal to h over 200. Again, you don't need to use the unit in the calculation as long as you have the unit in the final answer, especially if you have a word problem. So in this particular case, we're going to multiply both sides by 200. And the 200 cancels out on the right-hand side. So therefore, if I go 200 times the tan of 8 degrees, I'm going to get the height to be 20.1 meters is the height. So then we would write a statement and say that the approximate height of the tower is 28.1 meters. And that would be the final answer. Okay, this is your turn question. So again, I encourage you to pause the video and give this a try. Okay, I hope you've had a chance to try this problem. And again, we need to draw a diagram of the situation. So we have a ground, we have the tower, and it says we have a ladder that's leaning against the wall. It says the base of the ladder is 1.3 meters from the wall, and the angle between the ladder and the ground is 71 degrees. Now again, you have to read these questions carefully because sometimes they might give you the angle between the ladder and the wall. So you have to be sure to identify the correct angle in the problem. Question is, how far up the wall does the ladder reach? So again, we're looking for this height right here. So again, we're going to start with the tan of 71 degrees is equal to the opposite side, which is h over 1.3. Again, I'm going to multiply both sides by 1.3. And on the right-hand side of the equation, the 1.3's cancel. So now I get on my calculator, 1.3 times the tan of 71. And this works out to be, if you round off to one decimal place, 3.8 meters. So again, we would say the ladder reaches 3.8 meters up the wall. And that would be the answer to the problem. Now the next question, as you see right here, it says, how long is the ladder? So right now this side here is 3.8 meters. So again, we could use Pythagoras' theorem. We will learn a new way coming up forward, but right now we'll just use Pythagoras' theorem. So again, if you recall, this was 1.3, this was 3.8, and those are both in meters. So therefore, we're looking for the length of the ladder. We'll call that L. So therefore, L squared would be 1.3 squared plus 3.8 squared. And again, using your calculator, 1.3 squared plus 3.8 squared, that works out to be 16.13. And then if you square root both sides, you're actually going to get L to be plus or minus 4.01 meters. And why is it plus or minus? Because when we're solving a variable and square rooting, we get a plus and minus answer. However, because this is a length, we know that we only use the positive And if we round off to 1 decimal place, I guess that would be 4.0 meters. So again, the length of the ladder, our final statement, is 4.0 meters, and that would be your final answer. All right, so that ends section 2.2. There's a few word problems for you to try, so give those a try. And if you have any questions, check the answers on the class webpage.